In this video lesson, we're going to look at reduction reactions. So we'll look at reduction reactions involving organic compounds, specifically aldehydes, ketones, and carboxylic acids. So remember back to a previous video lesson that alcohols can be oxidized to become aldehydes, ketones, and carboxylic acids. And it's that carbonyl functional group makes the molecule very polar, and those molecules can then get reduced back to alcohols if they're in the presence of a reducing agent. So just a reminder, this one here is an aldehyde where the carbonyl is on the end carbon. This is a ketone, the carbonyl is in the middle, and this is a carboxylic acid where the carbonyl and a hydroxyl are on the terminal carbon. So we can reduce an aldehyde. It takes place in the presence of sodium borohydride, which is the reducing agent, and it happens under acidic conditions, and you end up forming a primary alcohol. So remember, primary alcohols underwent oxidation to become aldehydes in the first place. So that was the partial oxidation. And then you can see this is propanal, and we ended up with propanol. So in the reduction of a ketone, you form a secondary alcohol. So again, you use the reducing agent sodium borohydride in the presence of an acid, and you end up with a secondary alcohol. So the secondary alcohol means that it's on a carbon that only has one other hydrogen. The carbon is bonded to two carbons. So for the reduction of a carboxylic acid, this requires a stronger reducing agent than the other one. So in this case, we use lithium aluminum hydride in the presence of dry ether and still under acidic conditions. And in this reaction, you end up with a primary alcohol, because the carboxyl group obviously was on the last carbon. So you end up with a primary alcohol because the hydroxyl will be on the last carbon. We can also reduce nitrobenzene and reduce it down to phenylamine. And this is a two-step reaction. So first of all, nitrobenzene will be heated under reflux in the presence of tin and concentrated hydrochloric acid, and that will make the phenylammonium ion, and then that ion is then deprotonated, so a proton is removed in the presence of sodium hydroxide to make phenylamine, which is this molecule right here.